So let's do some of these problems. So I don't know. Well, this one's not answered because I did some of them in math lab. So I erased some of these answers. But let's do these last 15 problems. I haven't seen any of these, so it should be fun. Hold on. Where's the cap to my Apple Pencil? What? Alright, well, I'll find that later. Anyway, so number 16. Now, I haven't seen these questions at all, but number 16. The function's got those two asymptotes, add them together. Alright, well, that's fair. So horizontal asymptote is 1. It's 2 divided by 2. And the other one is negative 1/2. Solve the bottom for 0. So that's 1/2. Add them together. Alright, given the polynomial, which of its roots is not distinct? So which is a double root? Alright, well, it's not 0 because you can only factor out an x. I would just do the synthetic. 1, 2, negative 4, negative 2, 3, and like see which one I can do twice. That works. Can I do 1 again? Yeah, so it has to be D. Where is the lid to my Apple Pencil? Or the charging thing? It was just here. It got knocked off somewhere. There it is. There it is. Alright, much better. Alright, Apple Pencil intact. Alright, the number of pandas in Justin's backyard varies directly from the number of bamboo trees at the front of his house and inversely with the number of wolves in the nearby forest. There are exactly 2 pandas when there are 6 bamboo trees and 4 wolves. How many wolves are there when there are 8 pandas and 18 bamboo trees? I comprehended 0 of that while I read it. 0. Okay. The pandas varies directly with bamboo trees. So that makes sense. More pandas, more bamboo trees. And inversely with the number of wolves, which also makes sense. So there are exactly 2 pandas when there's 6 bamboo trees and 4 wolves. How many wolves are there when there are 8 pandas and 18 bamboo trees? I just have to set up the equations. I really don't understand that type of like inversely proportional and stuff. That's really hard for me. So I'm going to set up equations and say that K equal, or see, P equals K B and P equals N, which is just another constant, W, divided by W. Yeah. Because then if P is 1, W is N, and if P is 2, W is going to have to be 1/2. Okay. So that's true. And then there are exactly 2 pandas when there are 6 bamboo trees and 4 wolves. Do I need to just do this and combine them? I think so. And say that 2 equals 6 bamboo trees, K, over 4 wolves. So 8 over 6, K is 4/3. And then, so if I put that back in the equation, 4B over 3W, then I should be able to plug in 8 pandas and 18 bamboo trees. And then I can solve for W. So 8W is 24. So W is 3. Alright. I'm happy with that answer. I don't feel like I need to check that, really. Rationalize. So get the I out of the denominator. Well, that's not too bad. Because if I just multiply those together, like this, and then multiply the bottoms, then the bottoms is just going to be 5. And then I have to do that out on the top. So that's 4i minus 2 is plus 2i squared. And then minus 6 minus 3i. And then minus, I'm just going to do it in the parentheses, 6i minus 4 minus 3i squared, so plus 3 and plus 2i over, no, because all that's on the top of 5. And then I'm going to multiply by 5i, so the 5 is just going to cancel anyway. Cool. So I just got to do all that out and then multiply by I. So minus 6i plus 4 minus 3 minus 2i. And then I'll just combine. So we got I, negative 7i, negative 9i, and then we got negative 8, negative 4, negative 7. Okay. Times I. So that's still wrong. So let's look at the 9. Why how do we get the 9? So the 9's 4i minus 3i is I. I minus 6i is negative 5i. Negative 5i minus 2i is negative 7i. And then when we multiply it by I, that becomes negative 7i squared, which is positive 7 minus 7i. Nice. That was a good one. Ooh. Alright. Suppose those are the intercepts. And those are the intercepts in the rational function. That. Find the values of all this. So I gotta find the intercepts. So one intercept y is when x equals 0. So I could see that's 0 plus 0. So that's AB over E. That's what y is. And then I gotta solve the top for 0 to get the x-intercepts. So that's x plus a, x plus b. They use something weird like that up there on top too. So that's negative a and negative b. So negative a, negative b. So it's AB minus AE. Both of them should be minus. Yeah, that's definite. Excuse me. Okay. Consider the point AA. which lies in the first quadrant on that parabola. What is the slope of the line segment that connects this point to the origin? So it's just where it's equal, which means that is x, which means it's x squared plus 2x minus 8. It's in the first quadrant, so x is positive, but that's fine. It's x plus 4, x minus 2, which means we're looking at x equals 2. And what's the slope? Oh, well, the slope is 1 because they're the same anyway. You don't even have to solve for all that. Because if the points are the same, then from 0, 0 to AA, just what's the slope between those 2 points? Yeah. Okay. How many times does that function intersect with its inverse? None, right? There's another e, none of the above. 2 to the x is up here. And then that's right there. Yeah, that's got to be a none of the above. It's always scary answering none of the above. But that's definitely right. Alright. Solve for x over the real numbers. So I just got to multiply everything to get rid of the denominators. So I'm going to multiply that by x plus 3, that by x minus 1, and that by x plus 3. And that gets rid of everything. So we got x squared, now I'm just going to FOIL. So x squared plus 4x plus x minus 1 equals 2x plus 6. And then we'll get everything to one side so we can factor x squared plus 2x plus x, which is 3x, minus 7. We messed up somewhere, didn't we? That's gotta be right, though. Well, it can't be that because it's not defined there. Does 3 work? You get 2/3. You get 1/6 plus 3/2. 1/6 plus 3/2 is 10/6, which is 5/3. So that doesn't work. -1 is, you get -1. Over here, you get 1/2. 0, that doesn't work. -4, oh, that's the worst. So you get -2/5 and 1 over, so -1, -3 over -5. That's the closest, but that doesn't work either, right? Oh no, that's positive. That does work. Shoot. How'd that happen? That's x minus 1, that's x plus 3, that's x plus 3. We don't have the number here. We don't have the plus 3 here. So that's supposed to be a -4. Ugh. Yeah. Shoot. Alright. Much better. Okay. A given number is considered algebraic if it is the root of a polynomial with integral coefficients of any degree. of any degree. 2 is algebraic because it is a root of the polynomial x squared minus 4. Let S be a set of algebraic numbers, and let T be the set of all irrational numbers. What can be said about the conjunction of S and T? Conjunction. Shoot, I'm not sure what conjunction means. I'm just thinking conjunction is, yeah, and. Because otherwise it's union. It's union and conjunction. So, we're just going to go with some of them, but not all of them. My pencil's dead. Alright. Let f of x and g of x be polynomial functions with degree 2 and 3 respectively. If you add them together, or if you multiply them together, how many complex roots must the function have? Okay, well, complex numbers are real numbers, so we don't, that's just helpful, actually, not hurtful. So, if we add these together, it's going to be degree 3. And if we multiply them together, it's going to be degree 6. And then if we do 6 times 3, 18, and that's not an answer. If we add them together, it's 3, so h of x is 3. And then here we multiply them, so j of x is 6. And then if we multiply those, 3 times 6, what? That has to be E. That's really frustrating. I don't know. This test has already proved to be questionable. A to the x plus a to the x equals a to the x plus 1/2. Where a is positive and x is a real number. Find the value of a. Oh. Alright. Well, added together, that's not very convenient. We can make that 2a to the x equals a to the x times root a. So a is 4. Okay. That was a weird one. Let f of x be that. What is the value of those? Of 1 and negative 1? Well, you can just... Oh, it'd be more interesting if it was subtraction. Well, I guess since it's minus, some of them are subtraction. That's the whole deal. So you add them together, that's going to be negative 16. Those are going to cancel out. That's going to be... 4. That's going to cancel out. That's going to be negative 8. That's going to cancel out. This is going to be 12. That's going to cancel out. Yeah. That's pretty cool. Okay. So since they're positive and negative, a lot of them cancel out. So then you got to put them all together and say, well, those are 16. Those cancel. So that's negative 8. That's a good one. Alright. The line given by that is known to have a positive slope. Which of the following must be true? Well, so you gotta solve for the slope. Well, the slope is gonna be a over negative b. And we know it has a positive slope. So we know that that has to be greater than 0. So, like, they definitely don't have to equal anything. So get that out of here. A plus b or a times b. I think a times b. I think a plus b isn't going to do it. But a times b sounds pretty good. We need them to be different signs. That's all it really is. So we need them to multiply to be less than 0. Alright. 4 less than twice the number is 20% smaller than that number added to 4. What's the smallest integer that satisfies this claim? 4 less than twice a number is 20% smaller than that number added to 4. What's the smallest integer that satisfies this claim? Well, I don't think there'll be multiple. Because we're going to do, that's 0.8, so it's 0.8x plus 3.2 equals 2x minus 4, so we subtract that. 1.2x equals 7.2. Divide 1.2, divide 1.2, that's 6. Is that right? 6 is 4 less than 20% smaller. You're doing 20% smaller than this. You got to multiply it by 80%, right? I like all of that technique. It's 20%. I'm just going to try the different answers. So I plug in 4. 4 less than twice the number is 20% smaller than that number added to 4. 8. Oh, it can't be that. 8. 4 less than twice the number gives you 12. And that's 20% smaller than that number added to 4. That's also 12. What? That's why 6. 4 less than twice that number is 8. Is 20% smaller than 10. Jeez. 9. Is 12 the same? 4 less than twice the number is 20. No, that's not even smaller. 9. 4 less than twice the number is 14. No, it has to be none of the above unless I'm really misunderstanding things. That's a lot of e's. Given that quadratic, find the value of a that yields 2 maximum values on the domains 0 and 2. The value of A that yields 2 maximum values. Think lots of values. Maximum values on the domain 0 and 2. Yeah, 1 does. Right in the middle. Yeah, for sure. Alright. That wasn't bad. It was 25 minutes, thinking an hour for the whole test, so that's pretty good. Let's check our answers. So, B, C, D. B, C, D. And then C, C, A, C. C, C, A, C, E. Then do we have A, C, B? A, C, B. Ooh, that's not good. I got one wrong. I'm going to come back to it, though. D, B, B, E, B. D, B, B, E, B. D, B, B, E, B. D, E, B. D, B, B, E, B. Okay. So 25. 2 and 3. Then H must be 3. J must be 5 because you add them. You add the degrees, you don't multiply them. Oh, that's a dumb mistake. That's a dumb mistake. That's okay. Alright, I want to work on this other problem. Because I got it wrong earlier. And I want to make sure it's right. And then I want to code it in Desmos and see how that works. So the whole deal is... Well, actually, I can see a lot based on these shapes. If I put on some grid paper... can I add a new page, please? Thank you. So, we're going to draw a square. And then we're going to draw another square. They don't like that. The other square is of an indeterminate height. Oh, well, I can't change that. But then we draw a bunch of lines. We draw that line. We draw that line. We draw that line. And we draw that line. And then what we want to see is what happens as the outside square gets bigger. That's what I want to think about. If we make that really big, it just approaches that. I guess, yeah, it never does hit it. That's weird that it never does hit it. Okay, well, so here's the problem. Let's make that square smaller. So we've got that line, we've got that line, we've got that line, and we've got that line. And we want to find this area that I'm nicely going to color in right now. And the question is, yeah, to find that area. The one thing we know is the area of the small square. The area of the, or I'm going to say the side length of the small square is the square root of 70. Actually, you know what? This is my problem now. I'm going to change that. What can I make the side length? I'm going to make it 8. That's fair enough. So that side length is 8. So we need to find that area. Now, my first idea was to just kind of try to brute force it, to use these big triangles and subtract the little triangles. And so if I split it like this, you see I got that big triangle. It's just half. That has an area half of the whole square. So the whole square has an area of 64. So that has an area of 32. And then we need to subtract the little area. And that's where I wasn't sure what to do about this side. So I made that X, and that allowed me to find some things. What did that allow me to find? That allowed me to use similar triangles to find this height right here. Is I could say 8 over x is x is 8 plus x over... Oh, I'm doing really bad. That's a. That's the thing we're trying to solve for. 8 over a is 8 plus x over x. So we can say that 8x over 8 plus x is a. Is that little height there. So that height of the triangle is 8x over 8 plus x. So we can just use that to calculate heights of triangles. So then the area of that triangle is going to be 8x over 8 plus x times 8, the base, divided by 2. And then I guess we could have done it as one big white triangle on the bottom, couldn't we? So sorry, I zoned out there for a second. 8 times x. So now we're going to do the area of the other big triangle. So the area of the other big triangle is 8x over 2 minus 8x over 8 plus x times x divided by 2. And that should be it. Then we just have to simplify if we did everything right. So this is 4. So this is 32 minus 32 over 8 plus x plus 4x minus 8x squared over 4x squared over 8 plus x. So what we do now is we can combine things. So I'm going to go ahead and just try to combine everything at once. I'm going to say we got 32 plus 4x, and we're going to multiply that by 8 plus x. And then I'm going to I'm going to have the other stuff. So minus 32 minus 4x squared. And all of that is over 8 plus x currently. So let's distribute 32 times 8, 64, 128, 256. Plus 32x plus 32x, 64x plus 4x squared minus 32 minus 4x squared. Man, I think I messed up again. The left square, yeah, the left square is known to be a square. All right. So 32 minus 8x over 8 plus x. So it's the height times the base divided by 2, which is why that's 32. And then this is the height times the base divided by 2. The big one is the height times the base divided by 2. All of that seems legit. Should I try factoring a 4 out? Well, yeah, if I factor a 4 out, that really moves things along. These are both known to be squares. The problem is I know the answer, or at least I know what somebody told me the answer was. I'm just not able to get it. I didn't get it today when I tried it either. But it seems like I'm doing everything properly. These cancel and these cancel. Well, actually, no. Maybe I just didn't continue progressing. Actually, I think this is fine. So 3 or 2, 24. Okay, maybe not. Plus 64x. Can I do 224 divided by 64? Maybe. Like, what can I factor out of here? So you got 112 over 32. You got 56 over 16. You got 28 over 8. You got 14 over 4. You got 7 over 2. It's like one off from being able to fully factor. Is that the thing? So I can only factor out... I can't factor out a full 64 necessarily. I can factor out... So if I did factor out a full 64, it'd be 64 7/2 plus x over 8 plus x. That ain't very useful. Oof. We're trying to find the area inside the little boomerang shape. A 256 minus 32 is not a pretty sight. Oh! Yeah. Wait. No, never mind. I put that all over there. It really feels like I did everything right. The minus 32 is what's so weird. That's that triangle, 8 times 8x over 8 plus x divided by 2. Yeah. Alright, I'm going to try a totally different way. Well, not totally different, but let's just do giant triangle minus smaller triangle and not trying to do all these halfsies things. I don't know why. Sometimes things just don't come to me at all. I try to make things way more difficult than they need to be because my brain just doesn't see some of the obvious things sometimes. I mean, yeah, because then that's times x plus 8. What the frick? That was so easy. That's so lame that this didn't work, but that did. That makes that problem like not fun at all. It's still fast. No, actually, that's not true at all. It's still fascinating, but that's all it is. It's the area of the big one. The big, yeah, the big one here, which is 8 times 8 plus x divided by 2, and then minus the area of the small one, which is the height, 8x over x plus 8, times x plus 8, and all of that also divided by 2. So that cancels. You get, and that divides. So you get 4. Oh my gosh. You get 4 times 8, which is 32, plus 4x minus 4x. So the area of the whole thing is 32, which is decent. The whole interesting point is that the side lengths cancel out, which is, you have to know by the problem. You have to know that the side lengths cancel out because that's how the problem is solved. And so once I realized that, I was just like, well, what's going to happen is I make this really, really small and still do the same pattern. Well, if I do that, it's just going to turn into this whole triangle over here. And so to infinity, or to 0, I guess, it's just going to be that whole triangle. So if the side length doesn't matter, then that has to just be right. It has to be that whole triangle, which is area 32. So that's pretty neat. It is pretty neat that it all always cancels out and that the area is always 32. But yeah, really easy problem. I was just overthinking it, trying to separate it into 4 triangles. I'm still annoyed that I couldn't find my mistake, but I'm kind of tired, so I think I'm going to call it a day at that. So, thanks for watching, guys. I'll see you later.